Good morning, dear students. Let's start today's topic. Yesterday we have done exercise 1.2. Now we are in exercise 1.3. Before starting exercise 1.3, I will tell you some theorems, so you have to be focused on that. Theorem that is 1.3. If p be a prime number, if p divides a square, then p divides a, where a is a positive integer. They are saying if p divides a square, so it is compulsory that p divides a also. Okay, that theorem we will use in our questions also. Again I am telling, if p is a prime number and if p divides a square, then p divides a also, where a is any positive integer. Now let's start the exercise. Now I am telling you the next theorem, that is theorem 1.4, and that questions are very important. Every year one question is coming from like that. So you have to do, I will tell you something and you have to do these questions in your notebooks, and after that you will send me in my personal number. Theorem 1.4, they are saying prove that root 2 is irrational. What do you have to prove? That root 2 is irrational. So solution how I will do? They are saying that you have to prove that root 2 is irrational. So we are taking just reciprocal of that. We are assuming let root 2 is a rational number. Whatever we have to prove, we are taking converse of that. Root 2 is a rational number. If root 2 is a rational number, so we can write it in the form of p upon q. So we are writing root 2 is equal to r upon s. R and s are integers and s is not equal to 0. Suppose we are saying r and s have a common factor. So factor other than 1, then we will divide by the common factor to get. Then we cut it. Suppose any common factor is there, we are cutting it, and what we will get? A upon b. So we are saying root 2 is equal to a upon b. After that they will not divide. So where a and b are co-prime. Why we are say co-prime? Because we have cutted it. We cutted them. How much, what is remaining? We will check it. How much we can cut down? We have cutted down it. So what is coming? A upon b, where a and b are co-primes. But what is the main thing? What are co-primes? Co-primes are number who have not any common factor other than 1. Co-primes are the numbers who do not have any common factor other than 1. But you cannot cut it them down. So root 2 is equal to a upon b. And now we are doing cross multiply. So a is equal to root 2b. On squaring both the sides, a square, root 2 square is 2 and b square is b. That is equation 1. As you know, a square, if we will see that equation, so we can say that a square divide 2. Here 2 divides a square. If 2 divides a square, so 2 also divides a also. I have told you earlier that theorem. So we can write, so what we have, we can write a is equal to, if 2 divides a square, so we can write 2 divides a also. So we can write a is equal to 2 upon c. That is equation 2. If we will see these two equations, so what we will do, in the place of a square we will keep, in the value of a we will keep 2c. From equation 1 and 2, so a square was there. So a square means 2c whole square is equal to 2b square. If we will open the square, square of 2 is 4 and c square is equal to 2b square. When we will cut it, 2c square is equal to b square. If we will see it, so we can say b square is divided by 2. Here 2 divides b square. If 2 divides b square, the same theorem will come. So 2 divides b also. So we can write by theorem 1.3, if p divides a square, so p divides a also. The same is here. As I told you that a square is equal to 2b square. 2 divides a square. It means 2 divide a also. The same is coming. 2 divides b square. So 2 divides b also. Now see, we can write therefore a and b both divided by 2 also. But what we have taken, a and b are co-prime. Co-prime means they don't have any common factor, and when we are seeing here, we are getting the same common factor 2, which contradict our fact, which reverse which assume whatever we have taken, which contradict our fact that a and b are co-prime. This proved that our assumption is root 2 is rational number is wrong. Therefore, so root 2 is irrational. Again I am telling, root 2 is irrational. You have to prove. First we have chosen root 2 is equal to r upon s. R and s are integer and s is not equal to 0. Suppose r and s have any common factor, so we have cut it down them, then we will get r is root 2 is equal to a upon b, and after that we will say that root 2 is equal to a upon b, where a and b are co-prime. Co-prime means the numbers those who don't have any common factor other than 1. So root 2 is equal to a upon b. Now we are doing cross multiply. So a is equal to root 2b. On a squaring both side, we will get a square is equal to 2b square. So we can write, don't write like that, you just write 2 divides a square, or we can say 2 divides a also. So we can write a is equal to 2c. Here again we will see. So in the place of a we will keep 2c. 2c square is equal to 2b square. 4c square is equal to 2b square. So b square is equal to 2c square. Again we will see b square divided by 2. Yet 2 divides b square. So 2 divides b also. So by theorem 1.3, p divides a square. So p divides a also. A and b both divided by 2 also. So we can say a and b have a common factor 2. A and b have a common factor 2, which contradict our fact that a and b are co-primes. This proves that our assumption that root 2 is rational number is wrong. So therefore root 2 is irrational. Now I am giving you some homework. You have to prove that the following are irrational: root 5, root 7 and root 3. That is your homework. Okay, all the best. Stay in your home, stay safe.